Thank you for joining me on exercise 3G. I'm going to look at question 7a. This says prove the following properties of the modulus of complex numbers. So we've got the left hand side, z1 times z2, and the right hand side is the modulus of z1 times the modulus of z2. I'm going to start by let z1 be a plus bi, and let z2 is c plus di. And now let's work on the left-hand expression first. Left-hand expression is z1 times z2, the modulus. If we substitute a plus bi for z1, c plus di for z2. Now let's expand inside the modulus, and so we get AC plus ADI plus BCI plus BD. Okay, now to do the modulus of that, we have to get the real components together. So we've got AC and BD. And get the imaginary components together. So that is AD plus BC. That's the imaginary. Now the modulus, so we get the square root, and we square AC plus BD, square the real component, and square the imaginary component, AD plus BC. We may need to expand this to simplify, so let's expand AC squared, that's A squared C squared, plus 2 AC BD plus B squared D squared. That's the first bracket squared. Now the second bracket squared is A squared D squared, and double the product, so 2 AD BC, and then finally B squared C squared and I think there's something wrong here. Yes. Okay. Let's fix this mistake. This line here is BI times DI, and I said BD, but there's an I squared. So let's fix that. I squared. And that makes this BD with I squared. Since I squared is -1, BD I squared is BD times -1. So it's negative BD. So we change this into a negative BD, which makes that real component a negative BD here. Just that makes that a negative BD. And now let's change this is a negative BD. Now expand here, A squared C squared, this would be minus, and then that's plus. Okay, now we fixed up the mistake. The reason was this didn't cancel, and I was concerned we had too many pluses. Okay, let's move forward. And we've got A squared C squared, B squared D squared, A squared D squared, b squared c squared. Right, that's the left-hand expression. Now let's do the right-hand expression, which is z1 times z2. That's the modulus of a plus bi times the modulus of c plus di. So that would be the square root of a squared plus b squared. And we multiply that by the modulus of, so square root of c squared plus d squared. And that would be the square root of the product a squared plus b squared times c squared plus d squared. Let's expand that, see if we get the same thing. And we get a squared c squared, a squared d squared, b squared c squared, b squared d squared. Now matching, a squared c squared, yep. B squared d squared, yep. A squared d squared, yep. And b squared c squared, yep. Therefore, the right-hand side, the left-hand expression equals the right-hand expression, and we've proved it. And thus, quod etum demonstratum, what we were asked to prove. I hope this has helped. Until next time, stay happy.